Assalamualaikum warahmatullahi wabarakatuh and good day to my students. Today we're going to continue for the cable subjected to Uniform Distributed Load or UDL. Take this as an example. We have a cable supported at both ends and we have UDL along the way on this cable. And certainly we know the lowest point is here. So, what is the vertical force at that support and what is the horizontal forces at this support? So, for the vertical, this is the formula we're going to use, WL divided by 2. And this is the formula for horizontal forces, WL square divided HH. So, this is the reaction on the support for UDL on cables. So, how about the tensile force for minimum and maximum? We know our T is the cable resultant force of V and H. So this is our cable. We have tension in it, which is T, and we can resolve that into H and V, which is horizontal and vertical forces. Therefore, this is the formula for tensile force, H square plus V square square root. For the maximum tensile force, Tmax is H power of 2 plus V power of 2 square root, and its minimum when V is 0. Therefore, T mean equal to H, which is horizontal force. Take this for example, cable supported at different level. So we know the lowest point C. So this is the relation between length and the depth of support for cable support at different level. L1 divided by L2. So L1 from support A to the lowest point of C, then L2 the lowest point to support B. Then for D1 is from the lowest point to the lowest support, and D2 is the lowest point of the cable to the highest support. So we're going to use this relation. How about if our cable look like this? It's easy. You apply a mirror here, then we're going to have a mirror image of this side. Therefore, we're going to use the same formula as stated before. Here is L2, so this side is L2. Here is L1, so here is L1. And here is D1, so this side is D1. So this is D2, this is D2. So here is support B, here is support A, and the lowest point is C. So how about the length of cable? For the symmetrical, at the same level of the support, we're going to use this formula, S equal to L plus HH square divided 3L. However, for different support, we're going to use this S. Now let's do some exercise for case 4. This cable subjected to UDL of 3.75 kN per meter. We need to determine maximum and minimum tension in cable. As we can see here, this cable supported at same level. So we know at each support we're going to have horizontal and vertical forces at both support. So for vertical is WL divided by 2. So we know our W we know our L, so we can get our VA and VB equal to 28.12 kilonewton. Then for our horizontal forces, we're going to use this formula WL square divided by HH. We know our H is 1.8 meter to the lowest point. So we get our HA and HB is 58.59 kilonewton. Then we know previously Tmax equal to HA square plus VA square, and Tmin is equal to H because V is 0. Now let's calculate those forces. For the Tmax, our HA or horizontal forces is 58.59, so power of 2. Then for our V is 28.12 power of 2 square root, and we get our Tmax is 65 kilonewton. And for the Tmin equal to H. Then how about the length of this cable? So we're going to use this formula. S equal to L plus 8H square divided 3L. We know all those value, so we can calculate our S and we get 15.58 meter for the length of cable.